So this is some work that I've been doing with two other folks, Grant McKenzie, who's at McGill University, and Vidya Setlur, who's also on the Tableau research team with me. And it's a project that we call MixMap. And the idea is to help people explore this user-driven semantic similarity of places. So I think the first place to start is really, what is place? Because it is a word that we use fairly frequently, but I want to make sure that we're on the same page with how I'm thinking about it with respect to this project. And I think that this image of Coney Island is a really nice way of talking about place, because it shows this mix of uses that we see for a location, this mix of time of day. You see a lot of different things happening in this picture, and the way that people make sense of place is often tied to the things that are happening right now, the things that are important to them. So if you're talking about, do you feel safe in this place? It probably depends. Time of day, who you are as a person, perhaps your gender, perhaps your age, perhaps your mobility. There are a lot of things that influence the way that you conceptualize a place. So I wanted to just start with that, because I think this concept of place is very personal, and it's very driven by not just you as an individual, but by the question and the situation. So essentially, this just general concept of place, it consists of a lot of different dimensions, and only one of them is actually geographic space. Everything else is really quite fuzzy and personal. But the way that we often think about asking questions about space, especially in the geospatial world, is this very strict set of queries. You know, you might say, I want a location where the population density is greater than 100 people per square mile. I want somewhere where the household income is greater than $50,000. But then you might throw in some kind of crazy stuff. I want something that is near to the freeway. What is near? I want something that is diverse. But what is diverse? And those are things that you can't often express in a simple SQL query or a simple query in your GIS. So the situation becomes more complicated. And I want to give just sort of a quick example where something like this vague concept of similarity becomes important. So this is my grocery store. I'm opening up my new grocery facility in, Sarah's new neighborhood, and I know something about that neighborhood. And what I need to do is figure out, how do I decide what stuff I stock in my new store? Because I want it to be super successful. And I know where all of my other stores are located. And I know something about the characteristic of the locations around all of those other places. And what I want to do is think about, what is the situation? What is the place where my new store is located? And how similar is it to my other successful stores? Because if I find a place that's very similar, I can then use that as a model for how I want to set up this new store and have a higher likelihood of success. But in order to do that, I have to figure out what locations are similar and how they're similar to this place. And similarity is this really weird concept where it's super intuitive. Every day as we're going through our lives, we are looking at things that are similar to something we've encountered before. Or we're looking for references that are similar to something that we've been reading because we're focusing in a particular area of literature. Or maybe, somebody's put a bunch of shapes in front of us and we're trying to group them together because it's a card game that we're playing. And there are lots of different ways in which we can think about similarity. It might be related to color. It might be related to size. It might be related to the general shape. It might be related to the number of sides that each of these has. It might be related to the outline color. There are lots of ways that we can group them together and say these shapes are more or less similar to others. But we do it intuitively and often kind of arbitrarily. And arbitrary makes for really difficult, replicable decisions. So let's say we move to a geographic concept, and I want to find similarity across these 4 different attributes. So each one of these represents their census data, and they each represent the percent of a population. So one is percent African American, we've got percent Asian Pacific Islander, percent white, percent Hispanic. And if I wanted to find a location that had similar characteristics for distribution across all of these, it's difficult. Intuitively, what I'm doing is I'm looking at the lightness and darkness in terms of shades. There's this cognitive and perceptual process that's going on, but how do I integrate that across multiple different visual representations and have something that's quantifiable and reusable and that I can communicate to other people about why these places are similar, other than that stuff over there looks kind of the same. That's not a good quantitative measure, though I know we all do that a lot. That stuff. So you could look at maybe 2 or possibly 3 attributes at the same time, with bivariate choropleth map, a trivariate map, but that restricts you to the number of different attributes that you're looking at a given time. And we could probably argue how easy these are to interpret anyway, but at least it's a something, and it's pretty good for a couple attributes. But it's not great when you got a lot of stuff. So what Grant and Vidya and I did is we've put together this prototype system that we call MixMap. And the name from it came because as we were going through it, we felt like it was really kind of like a cool stereo system, because we had lots of knobs and dials. And what we were doing is we were dialing in different characteristics to try and understand what the impact of a different mixture of attributes was on thinking about similarity. So this is the general system that we put together, and I'll walk through what the various parts are on the system. The basic is you can pick a location, and we targeted census tracts for our initial prototype because it's a good generic unit that everybody knows, and there's a lot of data that we can collect about this unit. So in this case, I've selected a census tract, and I happen to pick the one here where we are located right now. So should you want to know what census tract Redlands is, or Esri is in Redlands, there you have it. And what it'll do is it'll color and code everything else on the map to give a relative similarity across all of the dimensions that we've put into the system. And so the tooltip that you can see on the left-hand side shows the detail that we provide. So this is census tract that I have the cursor over here, has a similarity match of 75%, and we'll talk about what that means. Has a similarity rank of 2,432. So of all of the census tracts in the area that's being evaluated, this is number 2,400 and change in terms of its similarity to my selected location. I know some details about the specific characteristics and how similar this tract is on each of the characteristics that we've input into the system. So we had age, race, income, education, commute, and a proximity characteristic that just looks at the relative distance. And so this tells you not only kind of the overall similarity across all of the attributes, but how it breaks down across the individual dimensions that we've incorporated into the calculation. We also provide some text information because oftentimes people just want to do a quick sort. Give me the top 5, give me the bottom 5, tell me how similar, give me some basics of the location. And we added in a little bit of naturally generated text to let people know you've selected a census tract, it's in San Bernardino County, there are 980 census tracts in 6 counties that we rank as very similar, et cetera, et cetera. So a little bit of a summary to help guide people. And all of this is interactive. So if you click on San Bernardino County, it will zoom you to the county. If you click on a census tract in the table, it will take you to the census tract, so you can explore a little easily. We incorporated a number of features to allow people to explore and to save their information. So we have a map type which goes between choropleth and just a binary most and least, and you can define how many you want in the top 5, top 10, top 100 type of thing. We have presets so that you can define mixes that are important. So measurement, different settings of the characteristics of interest. Location bookmarks so that you can store locations that are particularly interesting, and geographic filters. So this is where you can put in those nice SQL queries like, I only want census tracts that have a population density that is greater than such and such, and then use that for the comparison of similarity. We also allowed people to draw polygons to narrow the search area. So here I've drawn a quick polygon that narrows to the approximate Inland Empire. I grew up in the Inland Empire, so I feel okay making this very, very incorrect, vague cognitive region of Inland Empire. If any of you are also from the Inland Empire, we can discuss the boundaries of this region over lunch. This is a very generous Inland Empire. But we can then recalibrate similarity just to our area of interest. And then there's the really cool part of this. I think it's all really cool, but this animation is showing that we have these sliders. We have this mixer. So if you have characteristics that are particularly important or less important for your question, you still want to incorporate them, but you feel like racial distribution is the most important thing, you drag that slider. I don't care about proximity. You minimize how much that goes into the equation to calculate similarity. Education, super important. Let me drag that slider up. You can change these based on the question that you have, and then you can save them and you can share them. So if you're doing some decision making with your team, you can set your decisions for how you're calculating similarity, share them with the team, dialogue, have a collaborative opportunity there, and reuse them anytime you need to come back and make another decision. It is absolutely quantifiable because you can record the decisions that you've made. So to summarize some of the characteristics, we've given users control over the input. So what data do you want to put in here? And we chose a handful of census attributes just for the prototype, but it's a flexible system, so you can put in whatever you want and calculate similarity. The weight of how these different characteristics are being, how they're weighted inside the model. Geographic filters for location or attribute, as well as the map type, and added in opportunities for it to be collaborative so you can save and share these mixes for decision making with your colleagues, or to come back to them if you need to replicate. So a little bit about what's happening under the hood, because I think a prototype is always really, it's actually pretty easy to make a prototype that looks pretty cool. And does absolutely nothing that is even remotely useful. So I wanted to talk about the things that I think that we're doing that are kind of useful. We're using something called Jensen-Shannon divergence, which is a model of dissimilarity. So you can put in all of your attributes and it'll do this kind of multi-dimensional similarity or dissimilarity assessment to evaluate how these relate to one another. And I'm hoping that none of you are getting really great questions about the technical details on that in your head, because if Grant McKenzie were here, I'd be like, Grant is totally going to answer that question for you, and I am not. So bookmark that, and I am happy to get those questions to Grant because he did all of the mathematical modeling under the hood related to this. But the short story on what it's doing is we can take these distributions. So here I've got some made up distributions for tract A and tract B across the characteristics that we were considering: age, race, income, education, and commute. And we can calculate a Jensen-Shannon divergence value or dissimilarity value for each of those. And then we can add a human into the system. And they're like, cool, that's great. You've given me these values. Now let me do something with them. Oh, but what if there are like a billion different people that want to do something with these values? How do we accommodate that? Well, what we do is we allow you to define those user weights. And so any individual can define those user weights. We can sum those together and we can get an overall similarity value. So we end up with this big matrix of essentially every census tract by every census tract with a similarity value for any combination. And that gives us Mixmap, so that you can have this dynamic way of looking at any location of interest and being able to see how that compares on the dimensions of interest to you for the weights that are interesting to you, and get an easy to read visualization. You can also export and throw into other tools if you want to do additional analysis. Of course, we did some participant studies on this because we wanted to see if it was good. Prototypes are generally better if you know that people can use them. So we actually did some preliminary work talking with a subject matter expert, and then designed our system. And then we ran through it with a number of participants. It turned out they really liked it. And we got a lot of comments that were along the lines of, this is really neat. I could totally use this for insert the topic. My favorite was a colleague of mine who was doing work in looking at heat islands and the implication of heat islands and how temperature changes in various neighborhoods. And she needed to find 10 neighborhoods that were similar and 10 neighborhoods that were dissimilar, because she was really curious about these social justice and equity questions. But how do you find those neighborhoods and quantify them? And so we were talking about how she could use this. I think there are a lot of great applications, everything from these, looking for neighborhoods that are similar and dissimilar for study sites, to we're using this in the Racial Equity Data Hub at Tableau to try and make it accessible for people who are doing decision-making related to their data and want to take into consideration racial equity. Just all sorts of different applications, I think, for this. Next steps, expanding this out to make it easier to throw in your own data, opening it up with an API, and thinking about arbitrary geographies. So that is what we've done. I could probably even bring it up on my laptop in the break if anybody wants to take a look at it, because it is a pretty fun system. And I'm open to any questions that people have.
Okay, thank you for your presentation. I think it's an amazing app. I think I have a very short question. So I think you have used a variable called proximity. You said it represents the relative path or relative distance, right? So
yeah. Oh, sorry, go ahead.
So you have to calculate all the relative distance of all the sensor track in your data. That would be a huge matrix.
Oh yeah, this is a large data set. So
you have done that?
Yeah, so we just wrote a nice little Python script with some parallel processing that goes through and takes all of the census tracts. I mean, in our initial prototype, we actually just did census tracts in California, but it's still, many thousand by many thousand. And so we created a matrix for every one of our attributes of interest as well as proximity, which was just from the centroid of each one of those census tracts. And so we knew how far away they were. And my favorite thing to do on demos was just to turn all of the attributes off except for proximity, and it was just a little bullseye around any location, because everyone was like, what does proximity mean? I mean, I don't think any of you guys would ask me what proximity means, but like every human subject were like, so why do you care about distance? Like, you put the geographer hat on.
Okay, thank you.
I have a question, Sarah. Obviously, this is really awesome, and as you said, this has a lot of usefulness for equity-related issues, and there are a lot of organizations off the top of my head, including places I'm currently working with, that would find this immediately useful to make policy decisions in order to get funding to communities as well. So I'm just curious who the intended end user is and how they would get access to this when it is publicly available.
I mean, our initial, we started out with this really just as a pure research question. It'd be really interesting to understand a little bit more about the semantics of place and how people understand place. So between the three of us, Grant and Vidya and myself, we've got somebody who does a lot of semantics and natural language processing. We have somebody who does a lot of computational geospatial work, and somebody who thinks a lot about how people think about space. And we're like, wouldn't this be fun to explore? And we started exploring, and the Racial Equity Data Hub at Tableau was like, come explore with us. So that's the first place that we're making things available. And I think all of this is totally openish sorts of stuff. So we've got a paper that we finished up and submitted to the CAGIS Journal as part of this conference. But we'll probably do some more work on it in the coming years. But our plan is just to make this available. So if people want to run it right now, I mean, it actually runs with a single script. It goes to the census, it harvests data, it does all the calculations, it dumps it into some files, and then, we bring it up in our interface. So I think it could be made even more flexible. So let's talk a bit more about what organizations you work with would want and what kind of workflows work for them. Because the idea is that it should be flexible enough to add in whatever data is relevant. I mean, we picked a handful of attributes because they were kind of generic but interesting. But it could be number of students per school district, teacher-pupil ratio, average temperature. I don't know, whatever gets put in there, and the similarity calculation could be done with all of that.
Yeah, that'd be great to chat. Thank you.
Yes, thank you. I'd be very interested in exploring with you in the break. I was thinking, if hypothetically you have every tract and its similarity to every other tract, you could do an analysis of which tracts are most dissimilar to their neighbors And I'm thinking through some of the research questions that would be involved in that. Is that an application that you think you could do with this? And what sort of questions would you ask?
Yeah, I think we could do that. I mean, of course, with any spatial data, the finer your grain of analysis and the more of them that you want to use, the longer it takes to run the model and the bigger your data gets. But I think that, depending on how the question is framed and what the real goal is, if it really is this kind of localized proximity, that would be something you kind of could probably automate and walk through. For every county, do 4 orders out with neighbors, and then you've got a relatively small window for every county, and that's just a kind of repeating that calculation. Or we've thought about doing this scaled sort of system where you might do calculations to start on county level, and then when you find counties that are interesting, you zoom in on that county and then look at tract level. So it breaks down the number of calculations that you do and makes it so at that point it's probably almost tractable for an on-the-fly type of calculation. I think there are a lot of different ways to approach it. One of the questions that I want to dig into, and I'm hoping to maybe look at this summer, is migration patterns and looking for where are people going and what are the similarities between, on what dimensions are locations similar, because there are these great county level mobility data sets, and you can see, it may just be there are a lot of people there, so a lot of other people do move there, but there are probably certain characteristics that come out as being more or less important, driving some of those regional migration patterns, and I want to try and dig into some of that. But I think there are just so many questions that we could start to tap into. So let's talk a bit more. And I have a feeling I'm probably starting to run out of time. But looks like maybe Reggie has a question, and then I'll get Reggie's question and then.
Yeah, I think you just kind of answered it. I was curious about the similarity of one location. For example, if, a grad student, for instance, if they want to go from one location to a grad school in another location, does the similarity of the region they were in have anything to do with, that movement? Looking for a certain level of diversity or something like that, and how those kinds of parameters can be put into a system like this, or are you looking to make it work for something like that? You talk about the mobility.
Yeah, I think it's open to be able to put.
Yeah.
I mean, the algorithm's pretty generic, and so it's a question of what attributes then feed in. And just because we went to grad school together, I'll tell my humorous story about how I think you could use this well. When I took one of those spatial stats classes in grad school, Joel Michelson was teaching it, and one of his big examples was essentially finding all of the places in the country that he liked to do research to ensure that he would only be doing them in times when the temperature was acceptable. This is how we should totally be using these tools. Optimize for things like, I never want to wear long pants, I only want to wear shorts, things like that. I think it would be ideal, or for other more useful applications. So thank you, and I'm going to go get my list and find out who the next presenter is so I can moderate again.